I am Mr. Ish and I welcome you to this video where we're looking at this rational function, but we're going to utilize partial fraction decomposition technique to integrate this. Thank you for joining me. Partial fraction decomposition is ideally suited for this integral over here. When you look at the denominator, you have x into x squared minus 1. That's the denominator factored, but you can factor it more. It becomes x into x minus 1 and x plus 1. You're seeing three items arise over here, so therefore there must be three partial fractions which will come out. One is a over x, the other one will be b over x minus 1, and then c over x plus 1. When you do a common denominator, you know it's x into x squared minus 1, then you have to individually see how these go into that. Multiplying them with a, b, and c. A's denominator goes in that x squared minus 1 times. B's denominator goes in it x into x plus 1 times. And then lastly, c's denominator goes in that x into x minus 1 time. All of this in terms of the numerator will equal what you have right here. But you can write it in a good way, x squared plus 0x plus 1. Now you have to open up that entire expression. When you open it up, you're getting ax squared minus a plus bx squared plus bx plus cx squared minus cx is equal to that x squared plus 0x plus 1. Now you have some quadratic terms, and when you look at their coefficients, you have a plus b plus c is equal to 1. Then you have these linear terms. When you look at those, you have b minus c is equal to 0, and then you look at the constant term right here. You have here minus a is equal to 1, and then a is equal to minus 1. So you've already determined a, and it's easy. You bring that right over here. When you bring that minus 1 here, you'll end up having b plus c is equal to 2 because the minus 1 goes on the other side. Then you combine it with this. B minus c is equal to 0. Then do elimination. 2b is equal to 2, b is equal to 1. If b is equal to 1 based on this equation right here, then c is also equal to 1. So you've determined you have minus 1, you have 1 and 1. These are your solutions for a, b and c, which you'll put right over here. A will become minus 1, b will become 1, and then c will become 1, and these right here represent your decomposed partial fractions for that rational function, and now you can integrate that to completion. And now your entire integral question is just this. Integrate this, integrate this, integrate this separately, and you'll get your answer. This right here will give you minus natural log x. This here will give you natural log x minus 1, and this here will give you natural log x plus 1 plus c. But you can write this in a good way. You can do natural log x plus 1 plus natural log x minus 1 minus natural log x plus c, and this here would be your antiderivative for that, and the question would have been solved. So the partial fraction decomposition technique is ideal for this type of question because otherwise it would be very difficult. You would have to integrate by separating everything like this, 1 over x cubed minus x dx plus you'll have x squared over x cubed minus x dx. You could simplify this, but this right here would be hard. And these, in general, that route would be very hard. This route here is the ideal route to do, the partial fraction decomposition route. And that's it for this video. Thank you for watching. Have a great day.